Hi students, this is Sivakumar, 11th standard mathematics, chapter number 3, continuation of exercise 3.1. Now problem number 8. If tan square theta that is equal to 1 minus k square, then show that secant theta plus tan cube theta into cosecant theta that is equal to 2 minus k square whole power 3 by 2. Also, find the values of k for which the result holds. Problem number 8. Here is the question. Consider secant theta plus tan cube theta into cosecant theta. Secant theta you can write 1 by cos theta. The reciprocal of cos is secant, plus tan cube theta you can write tan square theta into tan theta. Tan square theta into tan theta that is equal to tan cube theta. Cosecant theta you can write 1 by sin theta. So what's the formula? Cosecant theta 1 by sin theta. That is equal to 1 by cos theta plus tan square theta into tan theta that is equal to sin theta divided by cos theta into 1 by sin theta. The reason for separating tan cube theta into tan square theta into tan theta, because we know the value of tan square theta. That's why I have separated tan cube theta into tan square theta into tan theta. At the same time, these two get cancelled. Sin get cancelled. So that is equal to 1 plus here 1 by cos theta plus tan square theta into 1 that is equal to tan square theta divided by cos theta. Now common denominator cos theta, you just add the numerator 1 plus tan square theta divided by cos theta. That is equal to 1 plus tan square theta divided by cos theta. You know the formula for 1 plus tan square theta, that is secant squared theta divided by cos theta can be written as 1 by secant theta. That's the formula. Cos theta formula 1 by secant theta. Cos and secant are reciprocal of each other. That is equal to secant squared theta into division become multiplication. 1 by secant theta reciprocal is secant theta. That is equal to secant cube theta. Okay. Now, you are given tan square theta. I write here, given tan square theta that is equal to 1 minus k square. That is given here itself. Adding 1 on both sides. Adding 1 on both sides. If we add, you will be getting 1 plus tan square theta that is equal to 1 minus k square plus 1. Adding 1 on both sides. You know the formula for 1 plus tan square theta, that is secant square theta. Because we have secant cube theta. That is equal to 1 plus 1, 2 minus k square. Taking square root on both sides. Secant square root is secant theta. Here 2 minus k square root, right inside that root 2 minus k square root of 2 minus k square, right? Let it be number 1, let it be number 2, equals secant cube theta can be written as secant square theta into secant theta. Secant square theta value here it is, that is 2 minus k square. Secant theta value here it is root of 2 minus k square. Equals 2 minus k square, right, as it is. Instead of square root, you can put half in the power. 2 minus k square power half. Here 2 minus k square, here also 2 minus k square. While multiplying, you just add the powers. You write 2 minus k square. What's the power here? 1. Here power half. 1 plus half that is equal to 1 and half. 1 and half that is equal to 3 by 2. It is proved. So first part is over. Secant theta plus tan cube theta into cosecant theta equals 2 minus k square whole power 3 by 2. Now we have to find out the values of k for which the result holds. The result is true. We have to find the values of k. How to find? So the given condition is true. Find the values of k. Okay. The result hold means the given condition. What is given actually? Given tan squared theta that is equal to 1 minus k square. Therefore, tan theta that is equal to square root of 1 minus k square. Taking square root on both sides. Square root of tan square theta that is equal to tan theta. Here, root of 1 minus k square. To find the values of k, I consider the expression which is inside the bracket as 0. Take 1 minus k square that is equal to 0. That implies minus k square that is equal to plus 1 comes right hand side minus 1. Both minus get cancelled. K square equals 1. Taking square root on both sides. K squared equals, k squared square root is k. Since we have square in the power, you have to put plus or minus, root 1 is 1. Therefore, k belongs to the interval minus 1 comma 1. How it is possible? We have to write the interval of minus 1 and 1. Listen. This is the answer. I draw a real line. Here minus infinity, here plus infinity. Here we have the numbers minus 1 and plus 1. Minus 1 as well as plus 1. I write minus 1 here, plus 1 here. Here what I have written, k belongs to the interval of minus 1 and plus 1. Look at the bracket. If you put the bracket, this is left closed, right closed, including minus 1 and plus 1. Not the normal bracket. Normal bracket represents excluding. This one including minus 1 and 1. In this range only k values are there. We can verify. I take one number here, full of positive numbers only here. I take number 2. If you replace k by 2 over here, 2 square is 4. 1 minus 4 that is equal to minus 3. Inside the square root we have negative number. Not possible. If the square root of a negative number is an imaginary value, so no chance of finding the value of theta. Okay. Suppose I take number here, any one number here, I take minus 2 or minus 3, even I take minus 3. If you replace k by minus 3 the whole square equals 9. 1 minus 9 that is equal to minus 8. Once again you are getting a negative number. Square root of negative number is an imaginary. So no chance of finding the values minus infinity to minus 1 and 1 to infinity. So that in between minus 1 and 1 can take n number of values. I take 0. If you replace k by 0, 0 square is 0. 1 minus 0, there is a positive value only. Even you can take minus 1. If you take minus 1 over here, minus 1 the whole square is 1. 1 minus 1, 0. 0 can come. Suppose I take 0.5. 0.5 here. 0.5 the whole square that is equal to 0.25. 1 minus 0.25 that is equal to 0.75. Once again positive value. So in between you can consider any values. Here it will be positive only. If it is negative, inside the square root if it is negative, no chance of finding the value of theta. Therefore the k values lies from minus 1 to plus 1. Okay. Here no chance, here no chance, here only possible. So problem number 8 is completed. I will be teaching the problem number 9 in the next video. Thank you children.